In this video, we are going to look at interpreting the variability of a data set. So in our example, the makers of a certain brand of light bulbs claim that the average life of the bulb is 1,200 hours. The lifespans in hours of a sample of brand A light bulbs are shown. How close to the claim were the light bulbs in this sample? So you can see that in the sample, they tested 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 times 2, 20 different light bulbs, and they just checked to see how long did the light bulb last. And these are the number of hours. So the brand claims that on average it has 1,200 hours. So you can see some of these are close to 1,200, some of them are kind of far away from 1,200. So question A, what type of data display will provide the best view of the data? So because the numbers in the data set spanned a large range of numbers, I guess we didn't even look at what the smallest to the biggest, but these are big numbers. We're in the thousands here. A histogram is going to be a good way to understand how the numbers relate to the claimed average. So let's go ahead and put together a histogram. Okay, so you can see that I just went ahead and created a histogram, so we didn't have to take video time for that. So just pause the video, go ahead and put this in your notes. All right, so hopefully you have this in your notes and we can just talk about it for a second. So frequency, number of light bulbs that fell within these intervals. So if you guys ever see this little, almost looks like a heartbeat on a medical device, what that's saying is that, we know that we start at 0 and we're just skipping over things, so we don't have to include every from 0 up to 1,000. And that allows us to start kind of where our data is. So I started 1,000 and just counted by 50. So 1,000 to 1,049, 1,050 to 1,099. And there were 2 light bulbs that lasted that long. And you can just kind of see what I counted by and how many there were. There were 4 in the next one. The next one went up to 5. This last one, there were 3, and then that last one had 2. So what does the display reveal about the data? So the data forms a bell-shaped curve. It is symmetrical. We can see that it kind of goes down on each side. If I were to draw in the curve, this is a bell-shaped curve. So data that has that shape will have a normal distribution. So we also know from our previous lesson that when you have symmetrical displays of data, that the mean and the median will be the same or very, very close in the middle. So in a normal distribution, we know that the mean would be right around here, which actually is 1,200. That was the company's claim. But in seeing the data displayed, we can see that it has that normal distribution. All right, so when your data is showing to have a normal distribution, the most useful measure of spread is our standard deviation. So let's just sketch out the standard deviation that we saw in our intro video. It's a bell-shaped curve. We have the mean in the middle, and then 1, 2, 3, we'll just divide it into 3, 1, 2, 3, and we know that certain percentages of the data will fall within 1, 2, or 3 standard deviations of the mean. So make that a little bigger. 34.1% of the data will fall within 1 standard deviation of the mean, either to the left or to the, oops, that's supposed to be a minus 1 standard deviation from the mean.
Then the next segment is 13.6%. And that is 2 standard deviations away from the mean. Again, we're just talking, here's the mean. 1 standard deviation away is 34.1%. 2 standard deviations is 13.6% plus the 34.1%. So that's how far away that is. And then our last one, we have 2.1% is 3 standard deviations away from the mean. And that was supposed to be a -2 and a -3. So we're saying that from here to here is 68.2% of the data, in this case our light bulbs, we can predict to be within 1 standard deviation of the mean, either 1 standard deviation above or 1 standard deviation below. If we look from 2 standard deviations away, that total 13.6 plus 34.1 plus 34.1 plus 13.6 gives us 95% of the light bulbs will be within 2 standard deviations of the mean. And then how much of the data falls within 3 standard deviations of the mean, this is going to be almost all of it, will be 99.7% of these light bulbs will fall within 3 standard deviations of the mean. So the standard deviation for this data set is 75.5 hours. So remember that formula we saw, that little equation in the intro video? If we did all that math, we would get 75.5 hours. So 1 standard deviation is equal to 75.5 hours. Remember, standard deviation is how far it deviates from the mean. So if our mean was 1,200 hours, and if I add 75.5 hours, that's going to tell me 1 standard deviation to the on the higher side, that's 1275.5. Or if I take that 1200 and I subtract 75.5, that's basically getting us to 1 standard deviation away and 1 standard deviation away. That's going to give us 1124.5 hours. So because 68.2% of the data fall within 1 standard deviation of the mean, that means that we can expect 68.2% of the hours of light bulbs to fall from 1124.5 to 1275.5. They're going to be that close to the mean. And the only reason that we're allowed to make this prediction and be probably somewhat accurate with that is the fact that when we graphed the data, we discovered that it had a bell-shaped curve, and so it was representing a normal distribution. All right, one more question to look at. It says, given that the life average of the light bulb is 1,200 hours and the standard deviation is 75.5 hours, what is the lifespan of light bulbs that are within 2 standard deviations of the mean or within 3 standard deviations of the mean? So here's kind of the way I visualize this. Our mean is 1,200. The standard deviation is 75.5 hours. So if I add 75.5 hours or subtract 75.5 hours, just take me in the other direction, that gets us to what we found in the last example, 1275.5 hours, and what was it, 1124.5 hours. So those were within 1 standard deviation of the mean. Now, 2 standard deviations of the mean means we would start there and go another 75.5 in either direction. That's going to give us 2 standard deviations away from the mean. So all we're doing is we're adding and subtracting. 1275.5 plus 75.5. That gets us to 1,351 hours,
That is 2 standard deviations away from the mean. If I take that 1124.5 over on the other side and subtract 75.5, that gets us to 1,049 hours. And that one is 2 standard deviations away from the mean. So how do you think we'd figure out 3 standard deviations away from the mean? Same idea, just wherever you left off, go ahead and go to the right another 75.5 hours, or go to the left, subtract another 75.5 hours. That's going to get you on the higher end 1,426.5 hours, and on the lower end 973.5 hours. Those are 3 standard deviations away from the mean. Because the standard deviation is 75.5. So we're just adding 75.5 1, 2, 3 times to get 2 standard deviations, 3 standard deviations away, or subtracting it in the other direction.